Hey everybody, this is Alex Merced, and welcome to the latest episode of Gnarly Datawaves presented by Dremio. My name is Alex Merced, and I am your host. And what I want to make sure to ask you all is to subscribe to Gnarly Datawaves. How do you do that? Well, you could either subscribe by going to youtube.com/Dremio and subscribing to the Dremio YouTube channel, so that way you never miss an episode, or on your favorite podcast receiver application such as iTunes, Stitcher, Spotify, Pandora, iHeartRadio. The list goes on and on. Wherever you listen to podcasts, you can find Gnarly Data Waves. So do subscribe. That way you never miss an episode. Okay, and then again, keep coming back alive here each week at the same bad time, same bad place. So that way you can ask your questions. Today's topic is going to be the total economic impact of the data lakehouse. And I just want to also implore you guys to try out the data lakehouse, because today we're going to be talking about the financial impact of the data lakehouse and how much money the data lakehouse can save you. Okay, so why not just try it out? Head over to Dremio.com and try out Dremio Test Drive to kind of get hands-on with the data lakehouse and try out to see what it's like to be able to query data directly from your data lake and be able to live query directly from Tableau and several other features. So head over to Dremio.com and try out Dremio Test Drive. Also keep in mind that on March 1st and March 2nd, the Subsurface Conference is here. Okay, our annual Subsurface Conference, the Data Lakehouse Conference, with all sorts of topics on data lakehouse implementations, best practices, governance, uh, data lake table formats, Apache Arrow, all sorts of really great topics that you're not going to want to miss. It's going to be going on March 1st and March 2nd. So do register right there at dremio.com/subsurface/live/2023. You'll still get there if you just go to dremio.com/subsurface, but just go there and register. So that way you make sure that you have your spot. And again, and that way you make sure that after the conference is all said and done, you're going to get that email showing you where you can listen to all the recordings for any lectures you might or talks you might have missed. Also, this year, not only is the conference going to be held virtually, we're going to have some physical locations over there in San Francisco, New York, and London. So when you register, just put in a request that you'd be interested in being one of the live locations, subject to availability. Okay. And if you're going to be at that New York location, guess what? You'll be able to get to meet me because I will be there. Okay. Waving hands, shaking hands, saying hello over there in the New York location if you happen to enjoy Subsurface from there. So I will see you there. And with that, and no further ado, let's get back to our featured presentation with our talk on the total economic impact of the data lakehouse. Our speakers today are going to be Caro Giordano, a consultant for total economic impact at Forrester Research Incorporated, and Tony Truong, who's a senior product marketing manager here at Dremio. With no further ado, the stage is yours, Tony.
Alrighty, thank you for the warm welcome, Alex. Hey everybody, thank you for joining today. Today's episode, we'll be going over the total economic impact of the data lakehouse. My name is Tony Truong, senior product marketing manager at Dremio, and today, joined with me is our guest, Caro Giordano from Forrester. So we'll start by going over the evolution of analytics. In the 80s, we saw the enterprise data warehouse come to life, right? You saw the likes of Teradata, and Netezza, and Oracle, and SQL Server, mainly used for transactional and analytical workloads. They were used to bring together data from across the organizations into a platform where it could become the single source of truth. But the problem was these data warehouses were mostly on-prem, meaning that storage and compute were pretty much fixed. They were hard to scale, hard to use, and became very hard to manage. And around 2010, we saw the introduction of big data and open source. We saw the Hadoop ecosystem come to life. We saw Hive and Apache, Drill, and Impala. It was used to analyze big data, so unstructured data, and we saw the rise of on-prem data lake. And like the enterprise data warehouse, it faced similar issues, meaning compute and storage were coupled together. It was still mostly on-prem, and there was a lot of operational overhead causing the cost to skyrocket. Around 2015, we saw cloud data warehouse enter the space. And this time, storage and compute were decoupled for the first time. But the problem was with these cloud data warehouses that you had to load data into proprietary systems, and you were limited to one processing engine. And we'll go over this a little bit more in later slides. And then what we're seeing now is the shift to the open data lakehouse. We call this the movement. So we'll talk about, open file table formats and how you can reduce the need to copy and move data. And what we observed after working with organizations that a lot of teams are having what we call competing data priorities. On the left-hand side, you have your line of businesses. This will include your end users, such as data scientists, your data analysts, and even your executive decision makers or external customers. And on the right-hand side, you have your centralized IT team, right? And the folks on the left-hand side, they want access to all of their data in order to make data-driven decisions. And at the same time, they want self-service. So they want the ability to curate their data and have the agility to modify that data, create a view of the data that makes the most sense to them without having to wait on IT to create that data for them. But at the same time, the centralized IT team needs to follow data governance best practices and ensure that the data that's being given out to the teams aren't just creating data sprawls, right? You want to make sure the folks that are getting access to the data are the right folks. And you want to make sure that the folks that are getting access to this data only see the data that they're supposed to see. In this slide, we'll be going over what I call the traditional analytics architecture. On the left-hand side, you have your data sources. You have your application databases, your log files, your web and social data, and any other SaaS application data. This slide may look very familiar to you because you may have seen this in your current organization or in previous teams. But what we typically see is that teams are copying data from these data sources into the cloud data lakes where it's cheaper for storage. And depending on how they implement the medallion architecture, they'll copy that data from the lake into the data warehouse where it's further transformed into a format where it can be easily consumed by the business. And it doesn't stop there because your end users, so it could be your data science team or your teams that need to build BI dashboards and applications, they'll need their own views of the data. And so they're not directly hitting the data warehouse. And what usually happens is we see teams copying that data into BI extracts. So you may see this be implemented as a semantic layer in the form of analysis service or like a Tableau extract, right? And so this is a lot of data copying. And on the other hand, you may see organizations don't even use data lakes. They'll copy data from the data source straight into a cloud data warehouse. And it's very rare to see an organization only use one data warehouse vendor, let alone one cloud, right? What we typically see is that organizations have a multi-cloud environment, and some even have a hybrid environment, right? So you'll have data that's sitting in AWS, some that's sitting on Azure, and some on Google. And the thing is, these cloud data warehouses don't talk to each other, and that's by design. And so what we see is that teams are copying data out of the data warehouse into cloud object storage, and then further copy downstream when they're ready to stitch together that data. And this a data governance nightmare. And with this data architecture, we see it impact everybody in the organizations. So from your data engineers all the way down to your end users downstream, right? And with data engineers, we all know that they're the ones working on data pipelines day in and day out. And we see three big pain points. The first is that they lose agility with this rigid data architecture. If there are changes in business requirements and reporting requirements, the data engineers have to be the ones that maintain the current data pipelines and also bring in new data. When they're bringing in new data, they have to work on these pipelines to make sure that they don't break. And so if the architecture is rigid to begin with, it actually hurts their productivity quite a bit. And the second piece is that there is no single source of truth, right? So building meaningful data applications on this data architecture is very hard. Like we talked about before, teams are copying data from your warehouse all the way into data marts and then aggregating them into BI cubes. And this is a very inefficient and expensive process. Right, the semantic layer becomes a physical data hub for a variety of teams, and then this creates data sprawls everywhere. And then everyone has their own version of the truth. And then there's conflicting business semantics and inconsistent data marts, which are problematic for data consumers. And finally, this one I feel like no one really talks about as much, but as a data engineer, it's very hard to advocate for yourself to your stakeholders. What I mean by this, when you're a data engineer and you're getting everyone the data that they need, you're sort of underappreciated, right? Because everyone gets all the data they need, and no one really questions anything because they have what they need. But the moment that data pipelines break, data aren't refreshing, end user asking, "Where's my data?" Then all of a sudden, you're the problem, right? Everyone thinks that data engineers is responsible for the data not being there. And this is where Dremio comes in. We make it easy for teams to get self-service analytics across all of their data. So what do we mean by that? We have a query engine layer that allows you to query your data that's in cloud object storage. So from ADLS, S3, GCS, we want to bring data warehousing capabilities to your data lake. And for teams that have to run a hybrid environment or need to keep the data sources on-prem for compliance reasons, we offer data connectors to allow you to join that data in with data that's in your data lake. And so you really get a unified view of your data. And so remember how I talked about, teams had to copy data from your warehouse or lake into BI extracts. So with Dremio, you get a unified semantic layer. And I like to call this the no copy virtual data marts. And so similar to how you would implement a medallion data architecture, you can create a semantic layer on top of all your data with our semantic layer capabilities. And so you can do your common data transformations in the bronze layer, and then in the silver layer, you can create that for your business users. And then finally, you can call the gold tier your access layer for apps and reporting tools, all in your data. And the best part about it is that your end users don't know that Dremio exists, right? So it just works seamlessly. It queries your data where it lives, and it's served to your data science team, your BI dashboards, and your other custom applications. And so the Dremio advantage is that you get self-service analytics across all of your data, right? You get that unified view of your data via our semantic layer with data that's on-prem, if you're running a hybrid infrastructure or all cloud, right? So we can do federated queries and join data across object storage, cloud data warehouses like Snowflake, and other data sources. We're built on open data, meaning your data is not locked into proprietary data warehouse formats. And so all of our data that we work with all of our work is based on community-driven standards, such as using Apache Parquet, Iceberg, and Arrow. And with Dremio, you get the sub-second performance of a data warehouse at 1/10 the cost. You get lightning fast queries, high concurrency, and most importantly, you don't have to have expensive data copies to manage. Here's an example of an organization that simplified the data architecture with us. We have Microsoft, right? Before Dremio, they were using a combination of ADLS, a data warehouse on Azure Synapse, Power BI, and Azure Data Explorer. One of the problems that they were dealing with is that it was difficult to get data into an easy and queryable format. They had a lot of ETL pipelines and Spark jobs, and they had about 50 terabytes of data and growing about 5 terabytes each day. And so the internal tool that they were building required a lot of data movement in order to get the freshest view of the data. And so when they needed to add more data sources, it means they had to add more data engineers. And then, as you know, more data pipelines means more maintenance. They were hard to create and even harder to maintain. And so after they worked with Dremio, they chose us because we had a rich semantic layer capability, and they were able to start using us for self-service data access. And now all the data is stored on ADLS, and now their analysts now have self-service access in building interactive queries on top of ADLS using Power BI. And then, with our security features, they were able to get dynamic security controls, which governed access and maintaining data lineage. And ultimately, this helped reduce data engineering workload and helped with increasing their productivity. So if you were able to reduce complexity and cut these costs associated with building and maintaining ETL pipelines, I think it's a huge win as a data engineer. right? You only have to maintain one single copy of the data. And as you can see, Microsoft is one of the many organizations who we have helped with implementing Data Lakehouse. The data engineers are now focusing on more high-value projects and spending less time on maintaining and updating data pipelines, which is a win-win for their productivity and also to help with end users with self-service analytics. With that being said, that wraps up my section of the presentation, and I'll hand things over to Carol, where she'll dive deeper on the report that we did with Forrester.
Thank you, Tony, and hi, everyone. That was a great overview of Dremio's Data Lakehouse platform. As noted earlier, I am a consultant in Forrester's TEI practice, and I was one of the project directors for this Forrester TEI study. A lot of what Tony touched on, I will explore in more detail as I take you through the study. A while back, Dremio came to us and shared some stories about how customers were using their open data lakehouse platform to enable data end users to run mission-critical business intelligence workloads directly on the data lake, eliminating the need to copy and move data into data warehouses or create cubes, aggregation tables, or BI extracts. Those were really good stories. And so at Forrester, we captured 5 of those stories and put them in a more structured analysis. In the next 20 minutes or so, I will take you through the findings of our analysis, starting with a definition of what TEI is, the thing that we at Forrester call total economic impact. I will also tell you what we heard from the 5 Dremio customers we interviewed, walk you through the analysis, and give you a framework that you can use to apply the same analytical recipe to your own organization. I think that we can all agree that making a business case is important when making decisions on technology investments. Forrester built its TEI methodology over 20 years ago because we found over 90% of IT decision makers in North America enterprises found value in a business case study. The question then becomes, what kind of business case to make? Because they vary greatly in quality. Forrester's TEI methodology is quite comprehensive. Most business case studies look at benefits and costs, but fewer look at risk, and none of them look at flexibility or future options. Let's just go through these 4 elements briefly. So hard benefits are the ones that end up on a financial statement. They're either ones that save you money or help you make more money, while soft benefits are those that have a less quantifiable impact on things like productivity or impact on people or culture, depending on the situation. Costs include license or subscription fees, but also time expended by customers to implement and maintain the investment. We also talk about flexibility, the opportunities or options that a technology investment today may produce for an organization at some point in the future. Whether or not the organization eventually exercises those options, the options do represent value for the buyer above and beyond the immediate benefits of the technology. They provide the organization with a more flexible roadmap for the future benefits. And finally, to make the financial analysis more conservative and defensible, we risk adjust the benefits and costs to anticipate the likelihood that this benefit will be realized across a wide range of readers, people like you who are looking at this study. We vary the adjustments for the different categories of benefits and costs based on what we know about the market and what we hear from customers. So this is our standard TEI development process. It consists of a number of steps, beginning with looking at existing research and conducting interviews with subject matter experts within Dremio to fully understand the value proposition of their open data lakehouse platform. We then conducted in-depth interviews with 5 customers to understand their journey, their experiences with the platform, and the impact it had on their organization. We took all of that testimony and constructed a representative financial model for what we call a composite organization based on the data received during the customer interview process. This is Forrester's way to provide organizations such as yours with a way to measure and evaluate the financial impact of investing in that solution. Finally, we wrote up the findings in a case study that presents not only the numerical analysis, but also the color behind it, sharing the stories from the interviewed customers. This was reviewed by one of our own Forrester analysts, Noel Johanna, before being finalized. Before I share our findings, Here are a few disclosures. The key points here are, first, this webinar is an abridged version of the case study. I encourage you to read the full case study, which you can find on Dremio's website. The case study was commissioned by Dremio, but Forrester retains editorial control. This is an objective third-party study of Dremio's Open Data Lakehouse platform, but does not imply an endorsement of Dremio. And lastly, know that your own mileage may vary. We recommend that you use the framework described in this case study to determine the appropriateness and the potential impact of a Dremio investment for your own organization. Now that we've got this covered, let's go into what we found through that process. First, though, here are some quotes from customers that we talked to. Throughout this presentation, I'll share several quotes from customers. I like this first one because it sums up the Dremio sales proposition nicely, how easily business analysts can access the data they need for real-time insights. This case study has many more quotes and stories from customers, which I encourage you to read in full. This slide sums up the results of the case study at the highest level. Through our interviews, we found that Dremio's Open Data Lakehouse platform delivers to our composite organization a return on investment of 387%, a present value benefits of 6.3 million, and a net present value of 5 million, and a payback period of less than 6 months. I will step through the details of how we arrived at this in the following slides. But first, for this study, I'm going to go back to the methodology. For this study, Forrester conducted interviews with 5 customers representing a wide variety of company sizes and industries, and in roles ranging from senior software developer, principal software engineer, senior architect of data management, lead data engineer, and business partner for digital and e-commerce. 2 of the 5 organizations were regional, US or European based, while 3 had a global footprint. They ranged in size from small, a startup managing under a terabyte of data, to super large, a global manufacturer managing several petabytes. Basically, companies of all sizes could benefit from the Dremio Lakehouse platform. When we talk to customers for Forrester's TEI studies, we typically start by asking them about the before state, what they were doing before the investment in Dremio, and what challenges they had, basically why they sought to make a change. Prior to adopting Dremio, the customers we spoke to said their organizations managed their data in multiple databases and warehouses. Some environments were purely on-prem, while others were cloud-based or in the process of being migrated to the cloud. Prior to adopting the Dremio Lakehouse platform, the interviewees noted that their organizations were becoming increasingly data-driven with explosive growth in the amount of data and the number of queries run against it. This overwhelmed the data scientists and staff architects who were trying to keep up. Data scattered in multiple databases was difficult to locate and combine, leading to the creation and maintenance of complicated pipelines and data joining workarounds. Data was copied multiple times in the process, taking up excess storage space and raising data governance and security concerns. Business analysts were frustrated by the lack of direct access to data, slow turnaround on queries, and reporting limitations caused by data architects struggling to catalog and manage access rights as redundant copies of data and reporting proliferated. So there were challenges all around holding back these businesses. Now let's discuss the analysis we conducted. From the customer testimonies, we created this composite organization, a hypothetical organization that represents the stories of these 5 customers. When we build these composite organizations, our goal is to take the characteristics of the companies that we interviewed and blend them together. The assumptions that we are using for this composite are, first, that it's a multinational organization. Could be any industry, really, with various revenue streams that rely on telemetry data to maintain business operations and drive new product development efforts. For this case study, our organization employs 5 data engineers and 10 data scientists who support 120 business analysts. Those analysts generate reports and maintain dashboards that serve more than 10,000 employees. Terabytes of data are produced daily and sent into a data lake that is currently 5 petabytes in size. After self-managing Dremio's Community Edition on a limited data set, the organization goes for it, signs up for Dremio Cloud, and begins to deploy Dremio for specific use cases throughout the enterprise. Analysts' use of Dremio within the organization roughly doubles each year as more departments and more lines of business get on board with the solution. In this case study, you can read about other assumptions we made about the time spent on tasks, the cost of infrastructure, and other aspects used to gauge the benefits and costs. Forrester collects a wealth of data on spending levels and trends, and we use some of that data to create or back up these assumptions. Now, let's explore the results of Forrester's total economic impact analysis of Dremio. From the stories we heard from the 5 customers, we came up with a number of quantifiable benefits, which we organized into 4 categories. The 2 biggest benefits come from efficiencies gained by the data scientists and the business analysts, and to a lesser extent, the data engineers. But there are also substantial data storage cost savings benefits as well. Taken together, these quantified benefits add up to a 3-year risk-adjusted benefit of $6.3 million for the Composite Organization. Now let's spend a little bit of time on each of these in more detail. The biggest financial benefit came from the impact on data scientist productivities. The customers we interviewed described how the Dremio Data Lakehouse enabled the organizations to shift the work of running data queries and producing reports from data scientists to the business analysts. This saved a significant amount of time, shortening time to insight and freeing up time for the data scientist teams to work on higher value projects like AI and machine learning. According to one interviewee, before Dremio, producing data reports was taking 2 FTEs, and each report might take 1 to 2 weeks to produce, communicating back and forth between the business analysts, the data engineering teams. After Dremio, they were able to push nearly all of that work to the end consumers. Another described how Dremio saved time by streamlining the data access control process. This person gave the example of a machine learning team working with a speech recognition project, which entailed having to collect data from multiple teams and go through multiple legal reviews and access control tickets. With Dremio, they were able to do that in half the time. For the Composite Organization, the total impact of this comes to just over $2.5 million over 3 years. Business analyst productivity was also significantly enhanced by users having direct access to data via virtual data sets residing atop the data lake. Business analysts charged with investigations could act on their hunches in the moment rather than formulating a query and waiting a week for a response. They could also more easily share results with others, leading to faster, more fruitful collaborations. These business users also appreciated Dremio's fast performance. According to one customer, we tested this, and in some use cases that had performance issues in the past, we don't have those issues now. Now, when you test something new, it's just a few seconds. When users are working in an exploratory manner, testing hypotheses and running different things to compare, that time really adds up. Modeling this benefit for the Composite Organization, the financial impact comes to $2.5 million over 3 years. The third category of financial benefit is data engineering productivity gains. These gains largely came through allowing users to run queries directly on the data lake, eliminating the creation of new data warehouses and data marts and the administrative work that attends them. We don't need to create the whole data warehouse to get to a data model. We could just push the data, create virtual layers for small requirements, and show them the value. What would have taken 4 to 6 months to set up a traditional data warehouse could now be handled in a 6-week sprint. Modeling this benefit for the Composite Organization, the financial impact comes to $445,000 over 3 years. Finally, because Dremio's virtual data sets eliminated the need for data copies, the customers we interviewed said their organizations eliminated redundant layers of storage. They achieved further storage savings through Dremio's data compression algorithms. Some were able to retire tools used in the ETL, ELT processes for further savings. Modeling this over 3 years for the Composite Organization comes to roughly $840,000. This brings me to a quick discussion, or perhaps not so quick given the number of them, on the additional benefits customers realized that they didn't quantify because it was not feasible to measure or they could not get the data. Most interviewees touted Dremio's ease of use as the biggest benefit, noting how features such as being able to write queries in SQL and the easy connection to BI tools fostered greater collaboration between teams and encouraged wider use of data in decision-making throughout the organization. According to one customer, as soon as we create a project, we create a directory for the group where the whole project team is automatically connected. This means everyone in the project can go into Dremio and see what their colleagues have done with the data. Dremio's Lakehouse platform also gave organizations a single portal, a single pane of glass through which to access data in the data lake. This eliminated the need for users to search different data repositories for the right report sources. Now we have one base for all of our reports. For me, that is a great advantage because I know how to go to Dremio. I don't need to know whether the data sits in one database or another. We connect the different data sources through Dremio, so I don't need to know which database to use. Now, by decoupling physical files from virtual views of the data on top, Dremio made data governance stronger and security and compliance easier for some, but not all of the interviewees we talked to. Data assets and access rights still need to be organized. In some environments, that could get complicated. One interviewee noted Dremio has a robust audit capability that provides visibility on how data is accessed and used internally. According to this customer, we could get very detailed information about how virtual data sets were created, information on any data leakage, and very detailed logs on everything that was happening. If anyone unauthorized tried to access strictly confidential data, the security team could look up the query. According to the interviewees, Dremio's Lakehouse platform does not require predefining the data before doing joins, so they're able to scale up quite quickly. According to one, we added more data, not only the growing number of data points, but also data from a separate data warehouse. And we were able to use Dremio to join it much easier than before. The rest of these you can find covered in the case study. Also in the report, there's a whole section on flexibility, how customers are anticipating further benefits by adding and connecting additional sources of data, both internal and external, and expanding access to Dremio to more users inside the organization, commonly referred to as the growing democratization of data. According to one customer, I'm pretty sure that in a few years, we'll have several hundred users. Even today, we just had a call with another use case that will start using Dremio. I'm going to spend a minute on the cost side of the equation now. Dremio offers a free, self-managed standard edition of its Lakehouse platform, giving prospective customers an opportunity to experience the platform at no external cost. The Enterprise Edition provides additional security and support for large-scale Lakehouse environments. Dremio offers both cloud and on-premises solutions. Pricing for the cloud is based on Dremio consumption units, which is based on compute engine size and processing time. Dremio also offers 3 levels of professional services, reflecting increasing amounts of hourly support. For the Composite Organization, licensing and professional services costs come to a little over $1 million over the 3-year period. Deployment and ongoing maintenance add another $260,000. So all of these things being said, the total economic impact of the Dremio investment for this composite organization comes to a return on investment of 387%, net present value of $5 million, and a payback of less than 6 months. I'm going to end with a few more quotes from customers. These are in detail in the case study report, and a lot of other stories in there. You can just read it and understand kind of where they're coming from and what they're experiencing. If you have any questions for me regarding Forrester's TEI methodology or the study findings, please feel free to contact me. If you have questions for Dremio, reach out to your account team directly. I'm sure they would be happy to hear from you and to help you. And with that, I want to thank Dremio for letting me share this story and the TEI analysis, and also thank you for joining us today to learn about the total economic impact of Dremio's Open Data Lakehouse platform. Again, I encourage you to download the report for all the details and more from the customers we spoke to. And with that, I'll hand it back over to Tony to wrap up.
Thank you, Carol. Hey, everyone. So now we'll go ahead and open up the polls for Q&A. So go ahead and drop in any questions you may have. And thanks again for your time.
Okay, we'll give a minute for some questions to come in. So again, if you have any questions regarding anything about today's presentation, do put them in the Q&A box at the moment. Let's see what comes in.
Okay, I think one of the questions came in, if I have data in a relational database on-prem, can I query that with Dremio? Yes. So we do have data source connectors. If you have data that's sitting on-prem, such as Hadoop, so HDFS, or any databases like Postgres, SQL, SQL Server, and then any cloud data warehouses, we do have connectors for Redshift and most recently Snowflake too.
Okay, cool. And then another question following up to that. How does the semantic layer on the data lakehouse benefit productivity?
Yeah, good question. So for this one, going back to the traditional architecture slide, there's a lot of data copying, right? So when analysts need data, they have to submit a ticket and then they get in the queue. And then with data that's on the lakehouse, you basically have data that you own is sitting in your object storage, whether it's cloud or on-prem, and you own that, right? And then instead of copying data from your object storage into a warehouse and then downstream into a BI consumption layer, you actually just query that data where it lives. And with Dremio, this kind of ties back into the first question. If you have any data that has to stay on-prem, so for any compliance reasons, or because it just has to stay on-prem, you can actually join that data with your other data in the lakehouse or in data warehouses, and then create that unified view of data. So think of it as like a single access layer for all your data points.
Cool. I'll speak to this next question. Is there any plan for Dremio to support Apache Hoodie? All I can do is I can speak to where Dremio is at the moment. So right now, there's no official support for Apache Hoodie. There is support to read and write Apache iceberg tables and to read datalake tables. There is, I think, an unofficial connector for Dremio software. So I think it was created as a third-party connector, so that way you can read Apache Hoodie tables on your Dremio. So we'll see how things evolve down the road as we continue to beef up our table format support. Right now you're going to have, again, robust read and write support right now with Apache Iceberg, read support with datalake tables, and again, that will evolve from there. So I'll leave that at that. And then
and to add on to that, Alex, he put out a great blog comparing OpenTable formats. If you guys haven't seen that, it's on our website. He really dives deep into those, the comparison between the three. So Delta, Hoodie, and Iceberg. Highly recommend that. It's a pretty good piece.
Yep. And another thing to keep in mind is that there are some interesting projects going on right now as far as like table format interoperability. So in the future, being able to work with multiple formats might be easier, but we'll see how those projects evolve as time comes on, and if they provide, again, a way where you can pretty much use any tool with any format in the future. But we'll see how those spaces evolve. Okay, Tony, how does Dremio licensing work?
Yeah, so we have a couple ways. So if you go to our pricing page, we have a free version. And then for the enterprise option, we have a pay per Dremio consumption units to basically compute. And then Dremio software has its own licensing. So basically, if you think of like a Kubernetes, you probably have to pay for that one. But yeah, it's mainly by DCU. So Dremio compute units.
Cool. Yes. So is there any mechanism for Dremio to optimize a storage layer in the data lake to meet performance SLAs? I'll let you, I can take this one if you want, or
yeah, you go ahead.
Okay, go for it. So basically, Dremio has a couple different angles on which it sort of optimizes performance. So it just depends on where you're running it. If you're running it on a Hadoop cluster, it's already going to kind of like cache things on the respective nodes that are doing the work. So basically, if you're handling it and accessing a particular data set over and over again, there's going to be a lot of caching that's going to go on that's going to continue to improve that performance right there on the Hadoop layer. When it comes to S3 or object storage, that's where Dremio's columnar cloud cache comes into play, where it's kind of essentially doing the same thing where it's caching a lot of things on the nodes that are on your S3. So that way it can get around some of the bottlenecks that occur on different object storage as far as accessing different items. So it is using a caching strategy and caching it in a way that's going to sort of take advantage of NVMe memory. So that's just at the storage layer. Then you also have additional types of optimizations like data reflections, where you're creating these iceberg-based materializations of any data set you want. So I could join a Postgres table with, actually now you could join a Postgres table with a Snowflake table, and then you can turn on data reflections and query it very performantly from Dremio. So that's super cool. And then on top of it, it's just built head to toe with Apache Arrow. So you're going to get all that benefit of using the Apache Arrow data structures, as far as being able to, one, reduce the amount of serialization, deserialization as you're working with different tools, and also just be able to transport it faster using something like Apache Arrow Flight. So at all those levels, you're going to get some speed optimizations to meet those SLAs. But again, on the storage side, there are caching strategies that Dremio uses. Whether you're using Hadoop file storage or you're using object storage, it'll have a caching strategy to make sure that it stays performant.
I kind of have a question for maybe the greater group, maybe keep this like a open discussion, but during the architecture history slide, we asked a poll question about, what does your data architecture look like? And thank you everyone for who responded. A lot of folks responded with hybrid and data lake plus data warehouse. And for those that did respond, I'm curious to know, what are some of your use cases and what are the data sources you're looking to do with?
Okay, so I guess if you have a response, put that in the chat, and then I will let Tony speak to the answers that come in. Okay, again, you're still more than welcome to submit any questions you want over to the Q&A section. Also, keep in mind, make sure to join us again next week, because next week we'll be doing a Hadoop modernization. So make sure you don't want to miss that. Let's see here. Okay, let's see here. We had a question. From through Debezium CDC into data lake. Okay, so now this is just like saying what their stack is. So they're saying they are replicating a relational database on-prem through Debezium, change data capture into a data lake. Okay, cool.
Oh, nice. Okay, thank you for that response. I'm not familiar with Debezium, but the replicating part, that makes sense. Hybrid.
Hybrid equals Hadoop ECS Oracle plus Azure ADLS ADX. So they got some on Azure, some on Hadoop.
Yes, that is a common use case we've seen, Hadoop modernization. So I don't want to call out your name, but you feel free to join our webcast next week. We'll go over that piece. So, having data that's sitting on-prem on Hadoop, such as like HDFS, and then modernizing the query engine, and then creating like a unified view of all your data. So you said ECS, Oracle, Azure ADLS, and ADX.
That's everything we got for now. So what we can do is we can start wrapping it up. So once I want to say again, Tony, Caro, thank you very much for being on this week. That was absolutely a riveting presentation. Definitely really puts to numbers to kind of what is the impact of a data lakehouse and what that data lakehouse can provide you. So that is super cool. Oh, I think we did get one more comment coming in. Cataloging across our express routes to ADLS times as a result of too many files. Okay, got it. So this is talking about like Azure storage timeouts. And again, those are the kind of things that like where Dremio can help with caching, or particularly Iceberg can help, because when it comes to object storage, sometimes you get like throttling because there's too many files under a particular prefix. Iceberg is going to allow you to actually be able to hash files within the same partition over multiple prefixes, so that way you can avoid some of those bottlenecks. So Iceberg provides a really nice solution to that particular problem. But yes, thank you both for coming. And again, everyone, make sure to join us again next week. So we'll be doing, again, Hadoop modernization next week. And we got some other really exciting topics coming up in March, along with make sure you registered for the Subsurface Conference. Again, that's March 1st, March 2nd. It's going to be a good time. And again, if you're in London, San Francisco, or New York, you can ask to see if you can get a spot in one of those locations where there'll be other really cool stuff going on. But with that, I think we'll wrap it up today. Thank you again. Make sure you subscribe on your favorite podcast application, whether that's iTunes, iHeartRadio, Spotify, and subscribe on YouTube at youtube.com/Dremio. So that way you never miss an episode. And I'll see you all next week.